Okay, welcome to JC Connect. In the previous class, we are discussing about the methods of disinfection. So, in that, we have discussed the physical methods of disinfection. So, physical methods that involves the disinfection by heat, disinfection by light, either it is from the sun or through an artificial manufacture of the radiation. So we already know in the electromagnetic spectrum, there are many rays will be there. Okay, depending on the wavelength and frequency, will apply to disinfect the water. Normally, the UV radiation is applied to kill the pathogens that are present in water. Then it depends on the depth of penetration and the time of contact. Also, it depends on the turbidity of the sample or the suspended solids that are present in the sample that we have discussed in detail. Then normally the chemical disinfectants that involves chlorine, bromine, iodine. So I already said that these are all come under the halogen based compounds. Even if you open the periodic table, in the periodic table, the halogen compounds are there, or halogen elements are there. So they are all considered as an disinfectants. So even the hydrogen peroxide is used, hydrogen peroxide and the potassium permanganate is used as a disinfectants. Some of the metal ions that are also responsible for disinfecting the pathogens. Alkali acids, they are also um, acts as an disinfectants, alcohols, phenols, and phenolic compounds. Even if you see some of the sanitizers that contains alcohol content, okay, with that you can understand that uh, the alcohols acts as an disinfectants. Then some of the surface active chemicals. Among surfactants, the cation active reagents or some of the detergents, normally what you use soap powder. Okay, that soap powder itself has acts as an disinfectants. It is going to kill the, the pathogens that are present in the surface. Remember, it is not in the bulk. Okay, it is on the surface. If any on the in the surface of the clothes or if surface of an any material, if it present if it present, then it is better to use the surface active chemicals. The surface active chemicals not only they are nothing but soap powder and the soap. Okay, even if you use that also, you are going to kill the pathogens. Okay, then some of the common methods will go in detail one by one. Um, the first one, that is the exposure to the sun. When you exposure to a sun, so you are going to kill the pathogens. Boiling, that is one technique where you are going to kill the pathogens. Then halogens, I already discussed this. Okay, chlorine, iodine, and bromine. They act as an disinfectants. Then ozone. Okay, so it is nothing but it is the, you can see this is O3. Okay, as I already discussed that even the sunlight UV rays, okay, you can produce the UV rays by artificial or you will get it from the sun itself. Okay, even that can be captured and it will be used as an disinfectants. Okay, then excess lime. So excess lime we can use the hydrated lime or unhydrated lime. COH twice or CaO. Then potassium permanganate, and where the formula is KMNO4. Okay, then silver Ag. Okay, then this acts as an disinfectant. Okay, So one by one, we'll discuss. Okay, starting with the disinfectant by heat. So normally the boiling technique, what we are talking about, okay. Um, Even the water can be disinfected by boiling for 15 to 20 minutes. For boiling water, all the disease-causing bacteria are killed and the water becomes safe for use. Okay, even if you boil the water for 15 to 20 minutes, they are going to kill the pathogens. See, one more very important thing is that once you say that it is disinfection by heat, it should boil. Remember, it should boil for 15 to 20 minutes. For example, just if you increase the temperature up to boiling temperature is normally it is 100 degree centigrade. Suppose even if you are maintaining only 72 or 80 degrees centigrade or 60 to 70 degrees centigrade, so then it is not going to kill the pathogens. Remember, okay. When we say it is boiling means 100 degrees centigrade should be maintained for 15 to 20 minutes. Okay. Sometimes many people will do that. What they will do is just they will heat for about 2 to 3 minutes. If you check the temperature of that water, it will be around 50 to 60 degree. So that won't work out. Okay. Most of the pathogens, what we are talking about, thermophilic pathogens. Okay. Thermophilic pathogens means they will resist the temperature even for 50 to 60 degree centigrade. They will survive. Okay, all the pathogens will survive even up to 70 degrees centigrade. Okay, that bacteria or the pathogens we can call it as thermophilic. Okay, so it is better to go for the boiling technique if you want to disinfect. That is the main thing we have to remember. Then by boiling the water, all the disease-causing bacteria are killed and the water becomes safe for use. This process can only kill the existing germs. Remember this. This process can only kill the existing germs, but does not provide any protection against the future possible contamination. See, whenever we are talking about the future possible contamination, see, in the previous class, I was discussing about the residual chlorine. Okay, why this residual chlorine is required? To stop the further contamination in the coming pipelines. For example, after water treatment process, okay, the water will go to the distribution network. Suppose in the distribution network, if any contamination is happened, okay, unknowingly, if any contamination has happened, so then that can be prevented by using this residual chlorine. But that is not possible in case of this. Okay. So once you heat, once you disinfect it, so that is over. Means it is safe for use at that point of time. Suppose if you are using that water in some other point of time or some other place, okay, or if you are transporting that water to any of the pipelines and then you are if you are using it, so then it's not possible to use it. Okay. This method is very costly because, as we have said, that if you want to boil, okay, you have to go for 15 to 20 minutes. So it has been predicted that 1 liter of water, okay, if you want to boil it in a stainless steel, okay, in stainless steel vessel. So then if you are running this for about half an hour, assume that the overall boiling is going to take place for half an hour. Okay. So then how much power it is going to consume? So they have predicted that it is going to consume around zero point 0.4 to zero point 0.5 kilowatt. Okay. It means half the units you are going to consume as per your if you see your meter boards, okay, in your houses, so So it is going to consume half unit. Okay, that is too much costly. See, half a unit means if you take the commercial charges, it will be around 5 rupees, half unit. In each unit, they are charging around 10 rupees. Okay, see, there are some slabs are there. Even if you cross 30 units, or even if you cross 100 units, they will charge and 10 rupees per unit. So starting it will from 3 to 3 or 4 rupees. It will start from 3 rupees. Okay, so it is go on increasing up to 10 or 11 rupees, 10 to 11 rupees. Okay, these are all the charges what they are making. It depends on, these are all depends on um, the how we are using it and what slab we are using it. Okay. So then this method is, as we said, that is very costly, because if you want to go for every day 4 to 5 liters of boiling, so then it is not economical. However, during the waterborne epidemics, public is advised to drink the water only after boiling it in their houses. So of course, this is the best method of doing the disinfection. That is why most of the doctors will recommend that even if you have the stomach-related diseases or the dysenteries, so the doctors will recommend you to drink the hot water. Okay, especially in rainy seasons or in the epidemics. So then, boiling, how much time you have to do it? Okay, 15-20 minutes. You are not supposed to do it intermediate. Okay, not immediate. Then no residual and costly. No residual in the sense, um, um, for example, if you want to drink this, the important thing of not immediate means, suppose if you want to drink it water right now, assume that I want to drink it right now. So you have to wait for the minimum half an hour. Okay, then it has to be cooled half an hour. Boiling, then it has to be cool. Minimum it will take half an hour. So immediately you cannot drink it. Okay, so you have to pre-plan it and you have to do it. That is the meaning of not immediate. Then no residual means, then residual, what we're talking about, the residual chlorine after disinfection process. In pipeline, if any pollution has happened, okay, it is not possible to do it. So these are some of the disadvantages, you can call it as disadvantages. Then it is costly. Then disinfection by ultraviolet rays. Okay, what we are talking about, UV. So ultraviolet rays are invisible light rays having the wavelengths of, I already said these, whatever the in electromagnetic spectrum we are discussing about. So it contains UV rays, alpha rays, beta rays, gamma rays, laser light, infrared ray, visible rays. Okay, just go through that electromagnetic spectrum once. Okay, if you go through that, so the UV light, it is having the wavelength of 100 to 400 nanometers. Sunrays also have the ultraviolet rays, which can be utilized by the disinfection of water. In the laboratory, they can be obtained by ultraviolet ray equipment, okay, which essentially consist of mercury vapors enclosed in a quartz bulb. Okay, mercury vapors enclosed in a quartz bulb and passing current to it. Okay, in naturally, if you are speaking, okay, these are obtained. These are obtained um, with the sunlight. These are obtained with the sunlight. But when in the laboratory, if you are producing it, okay, the quartz bulb will be there. Then inside the mercury vapors will be there. So when you pass the current in it, so it is going to emit. This quartz bulb is going to emit this ultraviolet light. Okay, these are highly effective highly effective. These rays are highly effective in killing all types of bacteria. The water to be treated with ultraviolet rays should be colorless and turbidity should not exceed 15 milligram per liter. Okay. Normally, the solids what we are talking about. Okay. The solids should not exceed 15 milligram per liter, and the turbidity unit is NTU. Turbidity unit is NTU. So, so up to 20 NTU you can do it, but more than that, if 20 NTU, if it is crossing, so then it has to be reduced to 5 NTU. Better, okay. 20 NTU itself is a maximum, but still, if you reduce to 5 NTU, then only it is possible to treat with ultraviolet rate. Suppose if the turbidity is high, so the UV light will not pass into the depth. Okay, for example, assume that if water is there, the UV light, if you are transferring from in this direction, assume that, okay, if you are uh, with this direction, then what will happen is that if it is more turbid, okay, then light will not pass. So once the light will not pass, then it is very difficult to kill the pathogens which are there on the bottom of this um, uh, tank. Okay. For treatment, the water is passed several times around the quartz bulb, emitting such rays. Okay. The depth of water over the bulbs should not generally exceed 10 centimeter, and so because these rays can effectively penetrate to this much of distance only. Okay. So it will penetrate up to 10 centimeters. Means even the depth of water um, in any of the tank where you are treating it, okay, it should not generally exceed 10 centimeters. So what we say is that UV rays, it is having the 1000 to 400 micrometers, or we can call it as 100 to 400 nanometers. Okay, then sunlight is required, or you can produce it with the artificial lamps, that is using the mercury vapor bulbs. Okay, then it can go up to 5 centimeter depth of water. So better efficiency. Removal of turbidity and color is essential. As I said, is that so pre-treatment is required. Pre pre-treatment is pre-treatment is required. So then no residual, and it is also costly. So one more disadvantage is that even the further contamination, if it is going to happen in the distribution pipelines or distribution network, so then um, just like chlorine, we cannot leave UV rays as a residue for to prevent the further contamination. Okay. But it is costly, as we know that it is costly because it involves the UV rays, and the producing a UV rays itself is a costly because we are using the HG vapor lamps here. Okay, the cost of HG vapor lamps is more. So, UV disinfection system component and its configuration. Some of the principal component of UV disinfection system, it consists of the UV lamps, um, and the quartz sleeve in which UV lamps is placed, a supporting structure for UV lamps and quartz sleeves. Okay, the ballast used to supply the regulated power to the UV lamps, the power supply which is used for the ballasts. Okay, there are two types of UV disinfection: open channel disinfection and closed channel disinfection. So forget about this. Normally, one kind of UV bulb will be there. Okay, so inside the vapors, mercury vapors will be there. Then sometimes this shape it will be there, or it will be of this shape. Okay, so they are going to introduce one small electrode here. Okay, just like your bulbs, if you open the tungsten bulbs in your houses, so we exactly center one tungsten or copper based uh, copper based type of material will be there, so that will be inserted inside. So when it is going to switch on, so the light will be on. So from this the rays will be emitted, and it will be captured. Okay, and it will captured by the water, and it is going to kill the pathogen. Suppose if you insert this in a tank, suppose in a tank or in a mm, in any of the vessels. Okay, then you add the pathogens containing water, then start the light. So even for about fraction, you can say within 2 to 3 minutes, so definitely it is going to kill the pathogens. Okay, so then there are two types of disinfection process. One is open channel disinfection process and closed channel disinfection process. So open channel in the sense, so normally one light will be there. Okay, the water will always flow from one direction to, it will be always on. This will be always on. In closed systems, the water will be, it is like a batch. There will not be any flowing water. Okay. So here we are going to maintain the uh, constant uh, head here. We are going to maintain the constant head here, or batch wise we are disinfecting it, and we are sending it. Okay, so batch wise we have to add, for example, 2 liters of water. 2 liters of water I have to add it. So I have to go for the UV disinfection process, then again the transfer it to one more vessel, then we can use it for any other purpose like drinking purpose and all those things. Then again take one more batch, disinfect and transfer it. So but in open channel disinfection process, continuous flow will be there. Okay, like this continuous flow will be there. So pulp will be always on by 24 by 7. When it is completely flowing, the bulb should be on for 24 by 7. So every time it is going to disinfect and it will transfer. So germicidal effectiveness of the UV radiation. So ultraviolet light is an physical rather than a chemical disinfectant. Okay, we'll consider this as an physical. Okay, it is emitting from any one of the source, and most of things we are expecting from the sun. So then radiation penetrates to the cell wall of the microorganisms, and it is observed by that nucleic acids, which are either prevents the replication or causes the death of the cell to occur. So even if you take a cell, single cell, suppose if UV light is going to hit, assume that this is a cell, okay, cell of you can say bacteria, pathogenic bacteria. So what it will is that when the UV radiations is going to hit to this cell wall of this bacteria, first thing what will what will do is that whatever the nucleic acids that are observed in this cell wall are going to alter. That's first one. Then it will stop multiplying the bacteria. That is the second major thing which is going to happen with help of the UV radiation. So once it is going to stop, once it is going to stop the multiplication of the bacteria, then you can say it is almost uh, inactive bacteria. So if it is active bacteria, so it will multiply one number of bacteria and it will be responsible for causing the diseases. So once it is restricting itself and killing the cell wall or cell of an bacteria means it is more efficient for the most of the killing the pathogens. Then effectiveness of UV distribution is depends on the the characteristics of UV distribution system. How exactly you are supplying the UV light. Okay, the overall system hydraulics. So what pressure you are maintaining, what head you are maintaining, what distance, what we are talking about, 15 centimeter thickness is required. Only that much it will penetrate. Suppose if it is higher than if it is 100 centimeters or 200 centimeters, it is not that much effective. Then the presence of the particles. Let us say that if more turbid, if it is more turbid, then this UV will not penetrate, then it is not effective. Then it depends on the characteristics of the microbes. What kind of microbes are there? Then it depends on the chemical characteristics of water as well as the wastewater. This the remaining things we will discuss in the next class because the dose and all those things is required. We have the discussion in the next class.